Welcome back, students. Let us see video number 43. Same chapter number 12 of physics part 2. Okay, in this video, we will discuss about atomic spectra. What is atomic spectra? In that GM experiment, we have seen one bismuth. It is excited by some energy, narrow beam of alpha. When alpha incident on a gold, there is a scattering of alpha, and the scattered alpha particle may strike on that ZnS screen. And when there is a collision between scattered alpha particle and ZnS screen, there was a flashes of light. Got it? And that flashes of light gives us some lines that is known as atomic spectra. Clear? Okay. Atomic spectra are of two types. First type is emission spectra. How we can obtain emission spectra? Let us see. Okay. In this, you have to excite atomic gas or vapor. Means atomic gas or vapor. This atomic gas or vapor is excited by, you have to excite with the help of what? With the help of electric current. When atomic gas or vapor is excited by electric current, after some time there is emission of radiation. Radiation of certain wavelength. Got it? Simple mechanism is there. When atomic gas or vapor is excited by electric current, there is emission of radiation, and this radiation having certain wavelength. Got it? This is known as emission spectra. This emission spectra appear, or it will give bright lines, and these bright lines are observed in dark background. Simple. Okay, so this is about emission spectra. Simple. Again, atomic spectra are of two types. Out of these two, first is emission spectra. How to obtain emission spectra? When atomic gas or vapor is excited by passing electric current, then it emits radiation, and this radiation having certain value of wavelength. Got it? It is known as emission spectra, and this emission spectra give us bright lights in dark background. You will check the textbook, figure number 12.5. 12.5 on page number 421. there is a figure which shows bright lines in a dark background. That is figure number 12.5. Got it? From this emission spectra, what we know? We can know the characteristics of that atomic gas. Which type of gas is there? What is its electron configuration, its atomic number, each and everything. Each and everything we come to know with the help of that atomic spectra. So, this atomic spectra is also known as, what is called? It is known as fingerprint. Fingerprint of any atom. Got it? Okay. Now let us see second type. Second type is absorption spectra. Okay, in this, what to do? Here, you have to pass white light. Means, instead of electric current, you have to pass, what to pass? White light. We have to pass from the gas. Which gas is there? That we don't know. Then it again emit radiation, and then transmitted light is observed by spectrometer. Means spectrometer, it is a device which is used to see that absorption spectra. Absorption spectra having dark lights, vice versa of this. Okay, so by observing that transmitted light in a spectrometer, that lines appear. Which dark lines you are getting in bright background. Bright background. Such spectra is known as absorption spectra. So, very simple things are there. Emission spectra as well as absorption spectra. From that atomic spectra, either it is emission or absorption, you come to know the characteristics of that gases. Whatever the gas we have taken, so it is known as fingerprint. Means atomic spectra is known as fingerprint of any atomic gas. Clear? Have a look for few seconds. Okay, now let us see the next topic. Atomic spectra, finished. Two types, emission spectra and absorption spectra. Okay, now let us see spectral series. Again, this topic is there on page number same page number, that is page number 421 of physics textbook number 2. Okay, spectral series. There is a figure number 12.6. It is again a spectral line. It is the spectral line for hydrogen atom. That spectral lines was invented by one scientist, Balmer. So it is also known as Balmer series. Got it? Balmer series is for hydrogen atom, okay, and that Balmer series is obtained for a visible light. So this Balmer series fall in a visible region. Got it? Simple. Means spectral lines having so many series, 5 series are there. Out of that 5, first we are taking Balmer series. So Balmer series was invented by scientist Balmer. That series is obtained for hydrogen atom. In that Balmer series, he used the line, which light? Visible light. So Balmer series fall in a visible region. There is one empirical formula for Balmer series, and that formula is 1 upon lambda is equal to R in bracket 1 upon 2 square minus 1 upon n square. What is n? N is nothing but integer number, and that integer number starting from 2 n starting from 3, 4, 5 and so on. Okay, if you are putting n is equal to 3 here, then you will get which line? H alpha line. Check it out. That page number 421, and there is a spectral line of H alpha line. That H alpha line having wavelength, while you are putting n is equal to 3 here, find the lambda, you will get the value 656.3. 656.3 nanometer. So that line is known as H alpha line. Means if you are taking first value of n, then you will get the wavelength. That line is known as H alpha line. If you will take n is equal to 4, then you will get H beta line, and this H beta line having wavelength 486.1 nanometer. Right? You don't have to remember that data. Why? Because just you have to put the values. Put n is equal to 3, you will get H alpha line. What is this? It is the wavelength of H alpha line. Put n is equal to 4, H beta line and its wavelength. And if you are taking n is equal to 5, then you will get H gamma lines. So that H alpha, H beta, H gamma, they are the spectral set. Means group of spectral line. It is there on page number 421. Okay, here what is R? R is nothing but Rydberg's constant, and this Rydberg constant having value which 1.097 multiplied by 10 raised to 7 meter inverse. It is a constant value. Okay, I am speaking frequently, page number 421. There is a figure 12.6. What is there in that figure? So, you will get this type of lines, this type of spectral line, right? On that spectral lines, you will find here what? H alpha. Its wavelength is 656.3 nanometer. Then after some distance, you will get which line? H beta line. Then as you go away, the lines become closer. That is H gamma line. Got it? So this is the H alpha line, which is highest. Highest means you are taking n is equal to 3, means first value of n, you will get the highest wavelength. Then and so on, if you are taking here, you will get the region where the lines are very close. So this region appear faint. There is no distinguish between lines, right? The lines are too close. It is very difficult to separate also, right? And this you will obtain at n is equal to infinite. Put n is equal to infinite here, then you will get lambda is equal to, I think so, it is 3 something is there. It is 364.6 nanometer. So it is the minimum wavelength. Got it? So here, if you are taking n is equal to 3, you will get the highest wavelength, that is 656.3 nanometer, and if you are taking n is equal to infinite, then you will get lambda is equal to 364.6 nanometer, which is minimum wavelength. Minimum wavelength of which atom? Hydrogen atom. This all about Balmer series. Okay, have a look for few seconds. Okay, then after this page, means page number 421, on page number 422 there is one more equation. What is that equation? Let us say this Balmer series is in terms of frequency. In terms of frequency. Then we know, what we know? Lambda is equal to C by F. What is F? Frequency, or there is one more symbol, nu. Okay, from that, let us see 1 upon lambda is equal to 1 upon lambda, take it inverse, is equal to F by C. So this equation, instead of 1 upon lambda, take F by C is equal to R 2 square minus 1 upon n square. Got it? If you want to find the frequency of that light, frequency of that spectral lines, then you have to use this equation, R C 1 upon 2 square minus 1 upon n square. Okay, what is R? Rydberg's constant. What is C? C is velocity of light in vacuum. Is it? Okay, let us see. After invention of that spectral lines by the Balmer took visible light. Then few of the scientists, they have taken ultraviolet and infrared lines. Then after they got the series of that spectral lines, that is the spectral series, let us say. Lemon series. Lemon series. It having empirical formula 1 upon lambda is equal to R 1 upon 1 square minus 1 upon n square, where n value starting from, leave this one, starting from n is equal to 2, 3, 4 and so on. Got it? And this Lemon series is for which type of region? UV. UV means ultraviolet region. Right? So these things you have to remember. Balmer series for visible light means Balmer series fall in a visible region. Lemon series fall on a ultraviolet region. Same things are there. If you are taking n is equal to 2, put it to here, find out lambda, it is for H alpha line. Similarly, H beta and H gamma. Lemon, Pascal series. It having empirical formula 1 upon lambda is equal to R 1 upon 3 square minus 1 upon n square. So 3, n value starting from 4 for H alpha, 5 for H beta, 6 for H gamma lines. Lemon, Pascal, bracket. Bracket series. That bracket series having empirical formula 1 upon lambda is equal to R 1 upon 4 square minus 1 upon n square. Here there is 4, n value starting from 5, 6, 7 and so on. Bracket, then Puffin series, that is 1 upon lambda is equal to R 1 upon 5 square minus 1 upon n square, where n is equal to 6, 7, 8 and so on. This last 3 series falls in which region? IR. IR means infrared region. Sir, why there is an empty space? That empty space is for Balmer. That is Balmer. So by this way you can remember all the series, that is 1 upon lambda is equal to R Balmer 1 upon 2 square minus 1 upon n square. Okay, and n value starting from 2, starting from 3, 4, 5, and this is for which region? Visible region. Okay, all these equations are true for few of the atoms only. this 1, 2, 3, 4, 5. That 5 equations are used for cinnamon, for hydrogen, singly ionized helium and doubly ionized lithium atoms only. Means these empirical formulas you can obtain the spectral series for only and only 3 atoms. Which are they? Hydrogen, singly excited helium, and third, doubly excited or doubly ionized lithium gas. Sir, how to remember this? So there is a technique. 5 are there. Lie, ba, pa, break, fast. You don't have to you don't have to speak that word among your father, like Papa breakfast, otherwise he will beat you. Okay? Lie. Lie, ba, pa. Lie means lemon, ba means balmer, pa means pasture. Lie, ba, pa. Break, pf, fast. Lie, ba, pa, break, fast. Okay, lie means 1. So here put 1 and value starting from 2. Balmer, ba, 2, put here 2 and value starting from 3. Then similarly, lie, ba, pa, break, fast. P1, lie, ba, pa, break, fast. P1, 5. So 1 upon 5 and value starting from 6, 7, 8. Clear? So this all about spectral series. This all about video number 53. Have a great day. Enjoy. Thank you.